Good morning, one and all physics students. Welcome to another edition of Finzics. It's Mr. Finn coming at you from neighborly Northville. Trying to ask this question: what happens when the voltages that we measure in the circuit do not add up to the total voltage stated on the battery? For example, my friends, I have a 1.5 volt battery. What if I put this battery in a circuit and then measure the total voltage drops, just like we saw from previous videos, but those voltage drops don't add up to 1.5, or I have two of them together and the total does not add up to 3? Does that mean the batteries are pushing at less than 3? Well, it could mean very clearly that there's some internal resistance to the system that we haven't measured. So, I'm not going to be long today, guys, but there's a section in your book called terminal voltage. And what that is an electromotive force, or stated voltage, minus this internal resistance times the current would give you the actual terminal voltage. Now, I'm going to set up my problem a little bit differently because I'm looking generally to find the internal resistance. But if you're given internal resistance, no matter, you would just use the current times the internal resistance to find that internal voltage drop and then get terminal voltage. I'll explain what I mean in a few minutes here. Hope you guys are doing well. Keep up on the Google Forms and your activities. Make sure you get those done on time too. A lot of guys are coming in late with stuff. So I have to evaluate when I'm evaluating and put the progress report stuff up on MyStar to let parents know how we're doing. So make sure you guys are doing stuff on time because that's my way of updating the parents on how we're doing progress-wise. Okay, guys, thanks. Let's go to the board and talk about terminal voltage. Okay, guys, we just have a simple example here, but let's walk through it step by step. The question is, what happens when the voltage drops that we add up due to these resistors is not the same as the total voltage? So, I have that question right here. Here's my general terminal voltage equation. This is electromotive force. This is the actual output of the battery as stated, minus the internal resistance, that's little r. When you see little r with no number next to it, that's going to represent internal resistance. Otherwise, we would have a resistor with capital R and usually some value like R1, R2, R3. My current, obviously, so Ohm's law. So any voltage minus my voltage drop will give me the stated terminal voltage value. Terminal voltage due to internal resistance. But this is best seen with an example. So let's take an example real fast. I have a 6-volt supply. I have a 2 ohm resistor and a 1 ohm resistor. Now guys, we know from our series circuit stuff that we can add resistors together. So 2 ohms and 1 ohm simply gives us 3 ohms. No problem. 6 volts divided by 3 ohms. Here's the addition of the resistors together. Here's Ohm's law, 6 volts divided by 3 ohms. That gives us 2 amps. So if I were to stick a meter in here, an ammeter, I should read 2 amps. But what if I don't? What if I read 1.8 amps? If we read only 1.8 amps, that means we've lost some voltage drop that we weren't particularly paying attention to. It must be internal to the system. Now, internal could be in the supply itself, could be in the wires, it could be in the measuring device. We really don't know. We would have to have some way of determining what the internal resistance was of wires or the battery supplies or the meters themselves. It's a little harder to determine. Well, let's move on. 6 volts minus the first drop. This is minus V delta, the applied voltage, which we described in previous videos. 1.8 amps is our regular new current, that's the one that we actually measure, times the 2 ohm, minus 1.8 amps times the 1 ohm. Well guys, we can just use 1.8 amps times the 3 ohms of drop, and that's 5.44 volts. So if I took 6 volts and subtracted 5.4 volts, I'd have a mysterious missing 0.6 volts. Well, where would that 0.6 volts go? Remember, it's lost due to internal values. So 6 minus 5.4 gives you the 0.6 missing volts. Now let's take 0.6 missing volts and apply the same current, because we know the meter is measuring 1.8 amps. So 0.6 volts minus 1.8 amps will give us our mysterious internal resistance. And the internal resistance comes out to be 0.33 ohms. There's an additional 0.33 ohms in the system that we did not account for. Internal resistance. Of course, when they ask for terminal voltage, you might be answering 5.4. But if they ask for internal resistance, now you've got a way of answering that question. Let's wrap up. Okay, guys, terminal voltage is just a small section that we are dealing with in our circuit section. But kids do have questions on this from time to time. So I thought it'd be a good idea to address it out front. Remember, when you get your homework going, terminal voltage could be the value that you get by adding up all the drops that you know with the current that you measure. Or you could be looking for internal resistance. Both are quite common. Tomorrow we'll look at Kirchhoff's laws. This is pretty complicated, guys, so I really need you to pay attention and get into those homework problems. Okay? Make sure to keep up with the midweek forms and, of course, the end of the week forms for Google Forms, all right? And get in that lab work for you. That's always good practice to get some stuff done ahead of the questions that we ask on a daily basis. Okay, guys, have a great day, and we'll see you tomorrow.